Good morning, everyone. Thank you so much for making your time, sparing your time on a Friday to come and be with us for a day of learning. Really looking forward to this day. And I would just love to, jump into our talk because we've already lost some time courtesy the Bangalore traffic. So, by the way, I'm not from Bangalore, so I have the liberty to say that for Bangalore, but I love it anyways. It's a fantastic city. But the talk that we have for today is 8 technology trends that all techies must know. Now, I have a certain pet peeve, and I'm sure Bharani as well here shares that with me, that every year, right, a lot of large consulting firms or any other technology consulting firms are going to release some interesting tech trends as the New Year's clock strikes 12, right? I'm sure you have seen that. Your LinkedIn, your Twitter is flooded with the next tech trends that are going to rule the world, right? The challenge that I have with those trends is that they hardly make any sense. Right? They are so far-fetched in the future that they're not relevant. You don't know how to sort of apply them into your daily business. And that's exactly the problem that we wish to solve, because we bring you the trends that are relevant for technologists today and now. And therefore, the invitation to all of you is take back something from what you hear today to apply into your daily business, into your engagements, into your projects, and see what you can make out of it, right? So we're not going to make you experts, of course, in the 45 minutes, but at least give you enough nuggets to kickstart your exploration journey so that you can learn and evolve more and use them. I think that's the most important thing. Use them right away, right? With that, let's get into the first tech trend, AI team assistance. Now, what's the first thing that comes to your mind when you think about AI-first software delivery? You can speak up. ChatGPT, what else? Like AI-first software delivery, what comes to your mind? Sorry? Copilot, GitHub Copilot, exactly. Right now, not to put you on a spot, but that's exactly the point, right? When we think about AI-first software delivery, the mind as a techie, as a developer, goes towards coding assistance or maybe test case generation, right? But last I heard, software development is a team sport, isn't it? To deliver any meaningful software, you need a cross-functional team, right? It has business analysts, it has a quality analyst, it has a product person, it has so many other roles, right? Now, my point or my proposition to all of you is, instead of looking for AI-first software delivery only from the standpoint of coding or accelerating your coding, can we take a step back and look at how can AI impact the entire software supply chain? How can it impact all the roles, all the cross-functional people who are part of your team, right? What does it really mean for the craft of a BA, of a quality analyst, of a product person, of a security person? What does AI mean for them, right? So that's the first trend about, to take you and make you understand that AI-first software delivery is not supposed to be myopic and only think about coding, but for the larger team that you have. Right? Let's look at this very interesting visual, right? And the reason I like this is it shows you that if given a pipeline, right, if you're only focusing on increasing the throughput of one part of your pipeline, you cannot reap the benefits as a whole, right? You can increase your throughput of coding, but can you hydrate your backlog faster? Can you break down your epics faster? Can you review your code at the same rate as you're writing it? Or can you put it in production at the same rate as you're, right? So you can imagine that if you're only looking at one part of your software lifecycle, it's not going to have the net impact or return that you are expecting from AI, right? So the invitation to all of you is to look at AI for the entire cross-functional team, because we are not looking for 10x engineers. We are looking for 10x teams, right? That's the key message that I really want all of us to think about. Not 10x engineers, but 10x teams, right? What's the art of possible though, right? Right from planning, research, analysis, design, development, you see, that's the art of possible with AI. I'm going to just, stay here for you to absorb this light. The idea is to not give you all this information, but to overwhelm you that what we think about is just a small blip in pink that you see on coding and test-driven development, right? But the art of possible is extraordinary, the X in the XConf, say, right? The art of possible is extraordinary with AI-first software delivery. It will impact the entire software value chain. Now, this is a typical blueprint that we have come to see and agree on how an organization that embraces AI for software delivery might look like, right? You can see for yourself, there is a chatbot. You can have an open source one if you're not quite comfortable with, as an enterprise, with the enterprise offerings like the ChatGPTs of the world. You can have a prompting platform where you can build apps with prompts. Diffie is a very excellent example of that, right? Now, you're already using, as a development team, some tools in your toolkit, right? You are using Atlassian, Confluence, Jira. You're using Figma for your design. You're doing SonarQube. You're doing tons and tons of tools in that software value chain, right? That's the yellow layer in between, right? There are going to be AI plugins or extensions that will come on top of it, right? There is a coding assistant that somebody mentioned from the audience, GitHub Copilot. There are many, many more varieties. There is JetBrains AI assistant. There is AWS Code Whisperer, and many, many more, right? But I want to draw your attention towards that pink box, which is the Team Assistance Portal. Now, what does this portal mean? Right? This portal is supposed to look like a way to share your good practices as codified prompts. So prompts, in my opinion, are quite underrated, right? If you devise a good prompt of how do you write a story, how do you do an epic breakdown, can you share that consistently within your teams? Is there a way for you to take that best practice from one team to the other? That's where a team assistance portal comes into picture. At Thoughtworks, we have built one. We have made it open source. I'm going to share the details. It's called Haven, right? This is a snapshot from that specific team assistance portal. And as you can see, it gives you a plethora of choices on, do you want to do some research on a given topic? Do you want to do some ideation? Do you want to do some design thinking? Do you want to do some what-if analysis? There are so many things that you can do beyond coding if you have some of these aspects codified as prompts into a tool like that we have built called Haven, right? This is a very simple architecture for this tool. Any engineering team can codify their practices, their good practices as prompts. Since it's a RAG-based tool, Retrieval Augmented Generation, you can seed it with your team's domain knowledge, the domain rules, the business rules that your team has, the tech practices that are important for you. And then when you try to use this tool with a given prompt, it can take all of that information to give you very contextual information on how you write your stories, how you write your acceptance criteria, how do you do design thinking and product thinking for what's relevant for your organization, right? And this is just the beginning, right? You can enhance it based on what's the context for your team, right? So a team assistance portal can be that one-stop shop for your entire development team to add and enhance the things that you want to automate with AI. And it can work with any cloud provider. You can point it to Amazon, Google, Microsoft, any model provider that you're comfortable with. This is the link for that Haven. I would really urge you that it's open source. Have a look, try it out in your teams. You can run it on your local machine as well. It's just a single container. And see for yourself on what a team assistant can do in your AI journey.
Right. Thank you. So when we actually put down the 8 trends, like me and Vanya were thinking, I'm sure we're going to be overwhelmed with Gen AI and techniques and tools, but we need to balance it out. So here is my part doing the balancing act. So before I go to the trend, how many of you have spent hours and hours explaining to your team members and to your clients about what is observability? And how many of you have to have this conversation? Observability is not monitoring, right? I think I've done this hundreds of times. Whenever I bring the word observability, people will say, oh, you're going to monitor something, right? And I have to say, oh, no, it is not. It's a lot more. And then blah, blah, blah. And then the usual culprits, right? You talk about 3 pillars. Observability is just not metrics. It's all about, tracing and logs and ability to debug your system without doing an open heart surgery, right? So we've done that. So if you've implemented observability, this picture should not be new. But let's say for some reason you are a user of observability or you're hearing it for the first time, it's a typical architecture what you would do. So this is from Aegir, the open source CNCF tool for this. You can infer there is a lot that's going on, right? You have your main system that does the business, that earns money, that does the ROI. But then you have tools to make sure that you can support and run and debug. And at times, these systems are much more complicated, much more expensive to operate than your main system. Right? Do you agree? Right. We work with one of the private banks in India, and I can speak for this architecture. If the entire transaction volume of the entire bank is X, the transaction volume of observability, can you guess how much orders of magnitude higher? 5x? It's roughly 10x, right? So then you take this call, can I store all the data and so on and so forth? And we go into this loop, but let's say when you have a problem, you still have to like work with individual traces, individual metrics, individual logs, and you have to correlate yourself, right? And this as an industry took us about, what, 5 or 6 years to standardize. So once upon a time, we had open telemetry, and then we had open sensors. Now we have open tracing, or the other way.
The other way around.
We had open tracing, open sensors, now we have open telemetry, right? So here is the attempt. The attempt is, can we do something better? Is this the time for us to take a step back and relook at what observability is? And can we do better, right? And hence, bump up the semantic version and say, okay, can we jump to version 2.0? And then what would that be, right? Okay, so that's observability 2.0. But before I present the trend, I want to introduce this concept of canonical logs. Have people heard of canonical logs? Do you know what a canonical log is? We all know what log is, right? Like, let's say if your service, your payment gateway gets a request, I'm pretty sure before it actually sends a response, okay, it's going to log, give or take 20 lines, 30 lines. So canonical log is a different approach. It says that don't log multiple times per request. Whatever that you're doing, I'm calling a Redis, I'm calling Kafka, I'm sending a message, I'm calling to a third-party API, keep aggregating, and before you send the response, write everything as one wide log, right? It's a very simple change, but it's very profound. Because what really happens is that if you look at the observability stack, if you make so many writes, you are putting a lot of strain on your storage and network, right? But if you aggregate and then log once, you're going to amortize all that, right? So if you're curious, there is this interesting paper from SQLite. Everybody uses SQLite, right? If you think you're not using SQLite, all of our phones are running at least 3 instances of SQLite today. So they wrote an interesting paper that says that, SQLite is 35% faster than the file system. Okay? And if you really think about it, a database is going to write to a file. How on earth can your database be faster than a file system? So it so happens that if you open a file, write and flush the file, the cost of opening and closing does add up when you do like 100 times a second, million times a second. So what canonical logs does is amortize all that. So instead of your service logging 20 times per request, you just log once and you log it wide, right? So that's canonical log. What I've been told, I think AWS has been using this for years and years, I've been told in the backend. Stripe openly wrote about it in 2019. So it's a well-known technique in the industry, right? But not a lot of people use it. So what is Observability 2.0? It's defined by this person, Charity Myers. She's the CTO of Honeycomb.io, one of the observability tools. It says that rather than thinking tracings and spans and metrics, think of canonical logs. And instead of always doing a search on what happened in a request, right? Instead of making it a search problem on read, it changes into a write problem. So you write whatever that's happening, metric, traces, log, all of them together, so you don't lose the context, right? So that's Observability 2.0. But what does it do, right? Like, if you have an observability system, the person who is most efficient to debug is often the person who has spent a lot of time with the system, right? But if you really think of it, the reason tool exists because you should not have all the context in the head. So what 2.0, at least the promise, is that it favors those who are curious over people who are having a lot of context. So if you're curious, you make a hypothesis, the tool is supposed to bubble up what has happened wrong. Right? But that said, so the question now is, we took 5 years to standardize on open telemetry. We have lots of tools now. Can you switch to 2.0 right now? You can. The best tool available for you is this long line and grep, and maybe honeycomb.io. But with all good things, the architecture transcends tooling, so you will see a lot more tooling. There is one referential implementation from Honeycomb. You can always use sed, gep, and arc and get away. But that's the challenge right now, right? And I want to say that one more thing that we're not ready is that not all data is created equal. I think as an industry, we should just embrace the fact that your observability data does not need the same HA, the same treatment, the same rate level as your transaction system. If you say yes, either you're lying to yourself or you have a very hard product owner, right? So implement tiering, and you have to invest in tooling. And this space is evolving, and we want to call that out that we care about the systems that we build. More and more, they are getting complicated. If you don't have enough observability tool, it's going to be really hard to maintain them, right?
All right. So how many of you here have ever dealt with a legacy application and you were tasked, or your team was tasked to modernize it? Show of hands. A lot of you. Excellent. Was it fun?
Okay.
Fun? You had a good time? What was the hardest problem in that journey? Sorry? Exactly. Right? So what are some of the challenges, right, that you encounter when you are tasked with modernizing a 40-year-old or a 50-year-old amazing legacy application? The first, it's a different language. It looks different, right? I mean, have you seen a TIBCO or a mainframe code? It just looks out of this world, alien, right? It looks different. You don't have the experts probably who built that code. You have severe lack of documentation. There is no clear understanding on what each and every variable, alien-looking variable name really means, right? So amidst all the hype, right, surrounding AI, this is one specific trend that I am personally extremely bullish about. Can I use AI to understand legacy code bases, right? Now, what does a typical modernization journey look like, right? You start with, hey, what's the purpose of this application? I want to do some assessment of the landscape of the apps that are in part of that legacy, sort of bucket. I want to sort of translate, reverse engineer, identify the dependencies, right? That innocent looking box right at the bottom, reverse engineering, right? What are the challenges? Agree with me? One of the most important challenges or most severe challenges while you are on a journey to modernize a legacy application. Now, what does reverse engineering really entail, right? What's the objective of reverse engineering? You want to understand from your giant legacy application, what are the interdependencies in your system, right? What are the various business logics and business rules that have been implemented in that system, right? What are the various breakage points, right? How one dependency impacts the other. You want to understand the as-is architecture. You want to understand the journeys, user journeys that are implemented in that system, right? And I would say that even before trying to migrate that to a newer modern tech stack, you are tasked with creating an understanding, an English language document on what the existing system is about. So far with me, does that make sense? That's a typical modernization journey. Now my question is, can I use AI to do reverse engineering of my legacy code bases? Can I? The answer is definitely you can. And I'm not sharing this from the air. We have tried this in several engagements of ours because typically reverse engineering is one problem that creates a lot of lag in the schedule of such engagements, right? And we have tried it on several of our customers' hardest problems involving mainframes, involving TIBCOs of the world, so that we can understand the legacy code with AI and make sense out of it to do forward engineering, right? So if I ask the question, how can AI help? AI can help in two ways. We spoke about software delivery. which is the forward engineering part. But what I'm going to talk about is how do I use AI to understand legacy code and make sense of it, right? Let's talk about the various tiers that get involved while I use AI for understanding legacy code bases. The first one is prompts, right? You try to understand a piece of code, explain this code to me, you give it a piece of code, you give it some context on what you're trying to do, and you use that, right? That's the first level, right? I'm sure you do that. If you're using any coding assistance today, you do that already, right? You sort of select a piece of code and say, explain this code to me, right? That everybody's familiar with. But is that enough? Usually legacy applications are made up of millions and millions of lines of code, right? Thousands of files. This is not a scalable way, right? Prompts alone. So what's the next step up that you can think of? That's where comes a RAG, right? Again, now can I vectorize my existing legacy code, store that in a vector database, and while I'm trying to give a prompt to my large language model, I take that context of that code, which is already vectorized, and try to make a better understanding of it. It takes me a step higher, right? The problem that I'm trying to solve here is, how is this concept implemented in this code base, right? It's based on my question, it's going to probably get the right code vector and make me better understand how a given concept has been implemented, right? Like it could be a simple, what's that user journey doing? What are the various domain rules in a given context, right? So that's a RAG. But is that enough? As I said earlier, just understanding one single concept, maybe not, right? You need to build the understanding for the entire code base. And that's where we have seen a lot of success with graph RAG, right? So you bring the power of graphs and RAG together. You try to create a structure using good old abstract syntax trees to understand the structural decomposition of your code, the structural dependencies of your code, put that into a graph database, and during your RAG, you fetch that structural information and try to add your context, and that gives you much better result. And this is the kind of concept that's going to apply to what are the various capabilities that are implemented at this entire code base level, because then you will do this comprehension of your code in the form of a graph for your entire code base, right? So this is something that has worked really, really well. I think if you are struggling with the legacy application, my invitation to you is explore this technique. There's a lot of effort that's happening. There's a lot of research that's happening in this space. We have built something of our own, but it's doable and definitely a way to really alleviate the pain of reverse engineering, right? As I said earlier, it's a combinatorial trend bringing together the good old abstract syntax trees, which preserves the structure of the code, the graphs of your code, and then you apply large language models and you put that all together. You get a graph RAG-based implementation to understand your legacy code bases. The RAG continues.
All right. So I'm sure you would have heard this a number of times in YouTube and events and conferences.
Retrieval, augmented.
Exactly.
Retrieval.
Yeah. So here is the thing. You have a bunch of documents, you have a bunch of structured data, you just store it in this vector database, and then you're done. You can implement RAG. Yes, no? That's probably the biggest shock of anyone who's trying to do GenAI products, right? It's good on a Hello World app. It's very good to get started, but very, very difficult to scale in production. Why? People don't tell you that, right? Because we go over the details of what it means to retrieve information. So information retrieval, or IR, is one of the hardest problems in the industry for the past 2 decades. So it used to be a problem for Googles and Bings and search engines of the world. Now what we have done, we've made that our problem when we are building like distributed systems with GenAI, because you have to solve the problem of IR, right? So I just want to highlight, have people seen this? This is the original paper where the RAG got introduced. I just want to call out 2 things, right? People talk a lot of context and how you can give context to AI. They miss the most important part, which is the instruction part, right? When the models started emerging, not all models can do instruction following, right? They're not instruction tuned. But right now, every model is. So that's what is RAG. So it has two parts. It has the context and an information to say that, you only learn from this context and nothing else, and don't hallucinate, and so on and so forth. So that's the RAG. Now I want to bring the focus back to R, right? And this trend, we wanted to balance breadth versus depth. So this is a bit more depth, so bear with me. This is what happens in a typical RAG, right? In some sort, it does not matter what kind of a vector DB you have or what kind of embedding models you have. You have a bunch of documents. It can be PDF, CSV, whatnot. You break it into chunks. It can be rows or paragraph. You index them, and you index them with an embedding model. Do people know what embedding is? Show of hands. What is embedding? Very few. Okay, so let me introduce this quickly. So let's say I take a picture of everyone, right? With my phone. Let's say I take a very normal picture, not a high-def 4K picture. Like that picture is going to have approximately 3 million pixels. Now, if I have to analyze what this means and infer that it's a conference and happening in Bangalore, that model has to work with 3 million data points, right? No model on the planet is smart enough to do that. Your GPT-4, the llamas of the world can't do that. So basically, you have to find a way to reduce the dimensional complexity from 3 million to something smaller, right? You can think of embedding as your gzip, how you compressed a text file, an image file. You're compressing. The only point where the analogy breaks is it's a lossy compression, right? You can unzip and get the original one with zip. With embeddings, you can't do that, right? So you are losing something, but you're compressing. With that context, this is what happens. You have two parts in the RAG where this can break. One is your embedding model. The other is the retriever, and I'll tell you why in like 2 minutes. With me so far? Yes? So what happens is this. There are like 2 points in time that's happening when you're building such a system, right? Let's say you have 100 PDF, and you have to put that in your vector store. Like at time 0, where there is no user in the system, you're just indexing those PDFs, right? That's your indexing part. And then the embeddings does the job. There is a compression. It stores all the documents and paragraph as vectors, which is just numbers. And that's good. But then what happens? You have the user in the system, and this person, he or she, is going to ask very interesting question. And then you're going to convert the question into the same embedding. The reason you do that is you can do a similarity search between your database that has the documents and the query. Now, here is the problem. The way the user asks the question is going to be totally different from what you have in the database, right? Like, if it is an exact match, you should be doing an exact keyword search. It's never going to be an exact match. So it's very difficult for the embedding model to do that without any loss, right? There'll always be that loss. And because of that loss, your vector similarity search is always going to be lossy, right? But that said, it's not a useless tool, right? Vector DBs of the world are really, really useful. You can think of them as bugs. Bugs do have a purpose, even though they are buggy by design, not by implementation. Vectors are useful, but you can't solely rely on that in retrieval, right? So what do? If people are familiar with BERT, Google released this long, long ago. There are many, many, many mutants of BERT, and this is one of the mutants. It's called CoLBERT. Without going a lot of details, I would encourage you to read the paper. So what CoLBERT does is that instead of compressing the paragraph where you will lose a lot of context, it stores every token, right? So your space for your index will grow, but that is the cost you pay for precision. And then at a later time, when the user asks the query is matched with every word in the document and not every paragraph in the document. So your chances of improving efficiency goes up. So this is one approach, and there are many more approaches. Vanya talked about graph, and graph is now becoming a lot more popular in retrieval, right? You don't have to do it by hand. There are fast graph implementation. There are tons of libraries out there, right, to do it by graph. There is also a third approach, and we have done this quite a lot. I think you will hear this in one of the tracks that's coming up by Sarang. It's how you do a hybrid search. Like how can you do a vector database search and also pair it with the good old textual search, which is otherwise called sparse index search, and how to do a hybrid. So in practice, this works a lot better than just using one approach, right? So that's our attempt to say that when you talk about retrieval, it's not a simple query and you get the document. 90% of your architecture is going to be spending time on how to get the data right. All right, so I'm going to do the next trend as well. Okay, I'm going to change the gear. It's not GenAI anymore. How many of you use GPay? Pretty much all. How many of you use linear? Okay. Superhuman? Mail app? No. Figma? Yes. So if you see where the money is going, right? If you, like everybody wants a fantastic app, right? The whole playing ground is almost commoditized. Like you can have the same API, everybody has the same set of tools. But where are these people, like Figmas and Linears of the world investing, right? Where is the money going? If you actually look at it, they're investing in the product experience, right? And I will tell you what it means. So if you want to take your phone, put it on airplane mode, you can do this experiment. And then go to your GPay and look at your transaction history. What do you think is going to happen? What will happen? Sorry? It won't work. How many of you say it won't work? You know this, right? Like the reason why I'm asking is that it's going to work, right? It's going to for sure work. You're going to see your beneficiaries, you're going to see your transaction history, everything is going to work. You can't send money, but you can see everything in your GPay. And the same goes for Linear, same goes for Figma. And why is that, right? It is not offline enabled app, right? Let's make that clear. So you have the online always connected app. You have features, some part of the features that will work offline. But we are now talking about local first software. So this, if you know Martin Kleppmann, he's one of the researchers of Cambridge. He wrote this famous data-intensive book. And orally, he's done a ton of research in distributed systems. And he wrote this paper for Ink and Switch, which basically means that you can build software now, which is local first, which basically has all these 7 principles. But one of them that is very interesting is network is optional, right? Which is completely different. So what it means is if you are using your app, the fact that you're connected or not is just a chance. You can comfortably work with the state that is in your phone or in your browser, right? When there is connectivity, it'll connect to the cloud. When there is no connectivity, it'll work with just the data. So no more spinners, no more HTTP requests to get the JSON and render. Imagine how quickly your paradigm changes of how you build products, right? But this is very, very hard. So if you're following what I was saying for the past 2 minutes, you should have lots of doubts. And we started saying all these trends you can try now. But implementing local first is really hard. Why? Because 3 reasons, right? It's very hard to sync, right? Let's be honest. We all work with Git. We know what happens when 2 people work on the same line of code, right? We have merge conflict. But we all use Evernote. We all use Google Docs. Have you ever seen conflicts when 2 people edit the same line? Why is that? Both are documents in some form. Why is Google Sheets and Evernote does not have conflict when people are collaborating? Anyone heard of this term CRDT? Yeah, conflict-free replication data type. So a lot of research has gone in, I think since at least a decade, of how to replicate without conflict. And that is very hard to do yourself. So what we're calling out that there are frameworks like Electric. You can have Postgres in your cloud. you have electric in front, and you can have your mobile phone, and you can define this is my data that I want on my device, and electric will do this two-way sync. So you can talk to your local SQLite on your phone. That's going to be in sync with your Postgres in the cloud, right? So that's all for you. One of the hardest problem. And then, sorry. I'm just conscious of time. So another problem is, what do you have on the phone, right? We always had SQLite, which is great, but if you want to do a lot more, and Vanya is going to talk about on-device inference and such, you need a lot more bells and whistles in your database, right? So PG Lite is a 100% port of Postgres for your mobile devices. So imagine running entire Postgres on your phone with just 2.5 megs of code, right? That's what is PG Lite. It's made possible because you're cross-compiling, or rather compiling to the device with WebAssembly, right? And the good part is, you can convert Postgres to a vector store with a PG vector extension, and you can have RAG in your phone and have a model infer, right? It's not far-fetched, it's possible right now. All right, so the other part is like, how can you collaborate? Again, there are lots of tools that make it easy to collaborate. Let's say you want to have it's almost like entering a party, and hence called PartyKit. You can define a room and collaborate with actors in the room and make it all happen real time. So that's PartyKit. And then the third biggest problem is, how do you do peer-to-peer networking? If you're building local apps, you need a way for you to connect without having a central server dependency, right? Again, calling out, there are lots of techniques that are available today that you can build to have a completely peer-to-peer app, right? So just summarizing, sync engines, there are quite a few options out there. There is Dexy Cloud, there is Electric. Ability to have a real-time collaborations, there is AutoMerge, there is PartyKit. And to have peer-to-peer network, you have DAT and Peers to actually make you build a completely local first app, right? All right.
All right, I'm gonna go a little fast because we are definitely lagging a little behind and we have 3 more trends to cover. But on-device LLM inference, right? What do you think is the challenge when you are using some of these proprietary models or the chat GPTs? Or what's the first concern that comes to your mind? Privacy, right? Exactly. Now, you are scared that can these proprietary model providers take your data and use it in whatever way they see? That's definitely a valid concern. And that's where I would say that privacy is one, but then there's also connectivity. Although we say that we are living in a connected world, but sometimes we do find ourselves in situations where the connectivity is lost, right? Or we do find ourselves in a place where we have to take care of responding to computations in very low latency, right? And of course, security, as we spoke about. That's background music saying yes, 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 right? And one thing that I would like to say is that any technology, right, becomes a lot more ubiquitous and a lot more democratized when it sort of gets integrated or invisibly into the devices that we use, right? My smartphone, my smartwatch, my smart machine, my smart TV, everything. Now, would you feel comfortable if all of this is talking to some cloud service? Probably not, right? That's where the value of on-device LLM inference comes into picture. It's not a new concept, right? On-device ML has been there for past many, many years, right? I'm sure if any data scientist in the room would remember that TensorFlow Lite released in 2017 that allows you to do on-device machine learning, right? It's not a new concept. But when it comes to large language models, immediately what comes to our mind is that for inferencing, they need a large compute-intensive infrastructure, right? So it sort of breaks that barrier that, do I really need such powerful systems to do LLM inferencing? And that's where this trend comes into picture. And let's understand what are some of the ecosystem enablers that are helping us push towards this trend of on-device LLM inference. The first one is explosive growth of the open source ecosystem, right? There are now models available, there is training corpora that's available, and all of this sort of pushes you forward in the direction of building local on-device apps, right? Bharani also spoke about that a variation of that. What is the other one? Quantization, right? How do I run a large fidelity model by compressing its weights and parameters into a small device, right? Maybe a Raspberry Pi, right? Or a sensor in an IoT ecosystem, right? So that's the sub-trend sort of under this theme, which is quantization. How do I compress a model, large model, and run it on a device? The second sub-trend under this larger theme is small language models. I think this is one interesting takeaway that would be really, really useful to all of you. Large language models, right? They understand a lot of things. They have multi-skills, right? They can summarize, they can translate, they can do natural question answering. But if you are really building specific applications or specific tasks, can you create smaller fit-for-purpose models, right? Which have less memory footprint, which have less number of parameters. You really don't need all the skills that large language models have for solving one thing right? The Unix philosophy, do one thing, but do it right. Similar thought process with the models as well, that build a model which is fit for purpose, which is very good for doing that one thing right. And that, again, is an enabler for bringing that model onto your system, right, onto your device. The last one is WebLLM, right? So WebLLM is an inferencing engine that runs right into your browser. So imagine creating all rich AI experiences right into your browser without having any connection to the central server, right? And this particular thing sits on top of Web GPU, which sits on top of WebAssembly, which I think Bharani covered in some shape and form, right? But these are some of the trends that are helping us move closer towards on-device LLM inference, right? There are libraries like transformers.js and Chatty. You can look them up. They are open source, which allow you to build AI experiences right on your mobile phones or your browser applications without any network connection that's required. And that, in my mind, is a very big step forward in creating and democratizing this technology, because a person working in a disaster situation with networks disrupted, if they really need to serve some purpose where they need to talk to the locals, they need this capability in their phone, right, without any internet connection. So that's a step change, and on-device LLM inference is definitely in that direction with these supporting enablers enabling this trend. This is a simple, fun picture for you. This is Stable Diffusion on your mobile phone, on your Apple mobile phone, right? Van Gogh style Labrador image. It used to take 23 seconds on your device. Now it takes 15 seconds. This is just the beginning. It's going to keep getting better and better, right? Apple has this Core ML framework, which they use to build on-device AI applications, train your models, inference your models on the device, right? Again, changing gears, synthetic data for testing and training models. If I ask you, while you're building enterprise applications in AI, what's the first and foremost challenge that comes to your mind? If you have to build a model or train a model or maybe fine-tune a model, what's that challenge? Data. Data. The answer is right here. Data, exactly, right? There is a talk in one of the tracks which talks about this specific challenge. And in that talk, Prathamesh is going to explain that for fine-tuning a model, it took them 50% of the time of the entire duration of the project to curate that data set, right? And that's where this specific trend is extremely relevant. Can I use synthetic data for generating test data, training data, fine-tuning instruction data for my models, right? Privacy, effort, and cost is, I think, are the aspects that I spoke about. But synthetic data generation for unstructured data, right? This is a simple example of such a model. It's called Bonito. This is a specific advice in this space, right? For structured data, I'm sure all of you are already quite aware of it, because for doing performance testing and load testing with our structured tabular data, we use a lot of synthetic data generation tools like Synthetic Data Vault and Faker, right? They are also deep learning models which understand the statistical distribution of your production data and then generate production-like data. But in the unstructured space, if you really want to generate fine-tuning instruction data for fine-tuning your models, it's a huge task, right? In order to do a suitable fine-tuning, you need approximately 25,000 to 100,000 data points. Now, that's a huge task to generate that data points, keeping your enterprise considerations, and that's where tools like Bonito comes into picture, based on whatever is the task that you're trying to teach to your model, whether it's translation, whether it's summarization or natural language question answering. It can use your enterprise annotated, unannotated text and convert that into a data point of a prompt and a response. such that you can fine-tune your model, right? You can learn more about it in the track, but Bonito is a specific advice. And this is sort of putting it together, right? As I said, models that can understand the statistical distribution of your data. SDV, synthetic data vault, is already a tool in that space. If you want to create adversarial data, bad data, to test your machine learning models for bias and inequity, you can use synthetic data again. If you want domain-specific data, right? Sometimes when you have to build a domain-specific small model and that domain data is sparse, you can use synthetic data generation for building that domain-specific data. And for sparse edge scenarios, right? In a banking world, fraud transactions are sort of outliers, and therefore that data is sparse. Can I use a generative AI model to generate that data for me, right? So that's the advice here, that whenever you think about any of these aspects that you see on the screen, your mind should immediately tell you that instead of hand curating data, we should look at synthetic data generation with some of these AI tools that are there in the space out there. And this is the
We
last
have almost time up, but I'll take 2 minutes and wrap it up. Have people heard of this term evals? Anywhere? Eval? Yes? No? Very few. Okay. It's also paired with one other word, right? And people sort of use it interchangeably, right? It's called benchmarking, right? So there is benchmarking and there is eval. I just want to end this trend with, there again, two different things, right? When we say benchmarking, it's exactly like that picture, which is also generated by AI. It's for people who are building those models, right? It's not for people who want to build products with those models, right? Let's get that distinction very clear. So there are thousands of metrics that tell the model creator, like Meta, Google, AWS, Hugging Faces of the world, to say that, how am I performing with the previous version of the model or with the new version of the model, and say, oh, I'm this much better than this benchmark, right? And that's what it is, right? So benchmark is for the LLM creators. Now, that is not to say that if it scores high on a benchmark, you're going to pick that model and use it in your product, because it says nothing about how the model is going to work for your specific task. So that is evals. So the difference between monitoring and observability, the same difference night and day between benchmark and eval. Even though they use similar sounding metrics, one is used by the creator of the model, one is used by us when we are building our own specific task, right? So that said, so what is eval? Eval is all about, like, here is what I'm asking the model, here is what the model is, I got you, right? Here is what the response is, this is how the RAG is working, and then you need some kind of a scorer to say, is this good or not good for a different metric, right? That's what eval is all about. But then the real question is, who's going to be the judge, right? Who's going to say the metric is good or not? Because these are not deterministic systems, right? They're going to have different responses at different point in time. So based on who the judge is, the kind of eval changes, right? So the first method of doing eval is called self-eval, which is like this picture, right? You're asking the same model and asking it to interpret and introspect. Why did you do this? Is it right? Is it faithful? Is it fair? It's like us trying to do a self-feedback in our appraisal, right? We all know how that goes. So maybe a useful technique, but not really practical. So our recommendation is it exists, you should be aware, but don't use it. So with that away, then what is the next big thing? Use a different LLM model to judge the output of another model, right? Preferably use a stronger model to judge the weaker model that you use in production, right? For various reasons, time, cost, you would use a different model. So like Prometheus is one such example. You can use many, many models for this. So that's LLM as judge. But this is probably the sensible default right now, right? Like 90% of what we do with evals is with LLM as judge. But that leaves the question, what's the remaining 10%? Any guesses? Human? What's the industry term for humans doing evaluation? Sorry?
White.
Somebody said.
Pilot. No, it's a cool term. It's called vibe checking, right? And I didn't make it up for this talk. It is a real industry term. The only good way, or rather one of the best ways to evaluate an LLM is to do a vibe check. And it's exactly like it shows. If it sounds right, it is right. Fine. So a human would write a prompt, will get a response, and will do a ARD, and you do that in an arena, and then not just one person, a bunch of people, and you score it, you get a leaderboard, that's your vibe check. I would say use both the LLM as judge and the human vibe checking in combination so that you get a good eval. So that's pretty much what we had. I know we went like 5 minutes over time. This is summary of all the trends. We did our best to balance and not flood you with all Gen AI, but we have to recognize that like when we used to draw the picture, we used to draw front-end, middleware, back-end. Not often we have another box. Now we have another box. So pay attention.
Thank you.
Thank you.